Step 1. Perform comprehensive diagnostics. Modern engines are equipped with sophisticated monitoring systems that track performance across hundreds of parameters. When something goes wrong, your car's computer stores diagnostic trouble codes, DTCs, that pinpoint the issue. What you'll need: quality, OBD2 scanner with live data capability, access to manufacturer-specific codes, basic understanding of common fault codes. The process: start by locating your vehicle's OBD2 port, typically found beneath the dashboard on the driver's side. Connect your scanner and turn the ignition to the on position without starting the engine. Run a complete system scan to retrieve all stored codes. Understanding the codes is crucial. For instance, a P0300 indicates random misfires, while P0301 to P0308 point to specific cylinder misfires. However, don't rely solely on codes. They indicate symptoms, not always root causes. A misfire code could stem from faulty spark plugs, worn ignition coils, fuel delivery issues, or even mechanical problems like low compression. Pro tip: if your scanner shows no codes but you're experiencing issues, perform a live data analysis while the engine is running. Look for irregularities in fuel trims, oxygen, sensor readings, and other parameters. Step 2. Restore throttle body function. The throttle body controls the amount of air entering your engine, making it critical for proper performance. Over time, carbon deposits accumulate on the throttle plate and bore, disrupting airflow and causing various drivability issues. Signs you need throttle: body service, erratic idle speed, poor throttle response, engine stalling at idle, reduced fuel economy. Cleaning process: begin by disconnecting the negative battery terminal for safety. Locate the throttle body. It's positioned between the air intake and intake manifold. Remove the air intake ductwork carefully, noting the position of any sensors or vacuum lines. With the throttle body exposed, inspect the throttle plate and bore for carbon buildup. Use a throttle body specific cleaner and a soft bristled brush to remove deposits. For electronic throttle bodies, avoid forcing the throttle plate open manually, as this can damage the motor. After cleaning, allow the throttle body to air dry completely before reassembly. Once reinstalled, you may need to perform a throttle body relearn procedure using your scanner or following manufacturer-specific steps. Step 3. Ensure optimal air filtration. Your engine needs approximately 10,000 gallons of air for every gallon of fuel burned. A restricted air filter can significantly impact performance and fuel economy, while potentially allowing contaminants to enter your engine. Inspection and replacement. Access your air filter by opening the airbox housing. A clean filter should appear white or light colored with clearly visible pleats. If it's dark, oily, or clogged with debris, replacement is necessary. Modern engines use various filter types: panel filters, cylindrical filters, or cone filters in performance applications. Ensure you're using the correct filter for your specific engine, as fitment affects both filtration efficiency and airflow characteristics. Quality matters. While aftermarket performance filters claim increased airflow, stick with OEM specifications unless you've made other engine modifications. The factory filter provides the optimal balance of filtration and flow for your engine's design. Step 4. Clean the mass airflow sensor. The mass airflow (MAF) sensor measures incoming air volume and density, allowing the engine control unit to calculate the correct fuel delivery. Even minor contamination can cause significant drivability issues. Symptoms of MAF: sensor problems, poor acceleration, irregular idle engine hesitation under load, check engine light, black exhaust smoke. Cleaning procedure: locate the MAF sensor in the air intake tract between the air filter and throttle body. Disconnect the electrical connector and remove the sensor from its housing. Use only MAF sensor. Specific cleaner. Never use carburetor cleaner or other solvents, as these can damage the delicate sensing elements. Spray the cleaner on the sensor wire or plate elements, allowing it to dissolve contaminants naturally. Allow the sensor to air dry completely, typically 10 to 15 minutes, before reinstallation. Never use compressed air or attempt to wipe the sensor elements, as they're extremely fragile. Step 5. Maintain proper lubrication. Engine oil serves multiple critical functions: lubrication, cooling, cleaning, and sealing. As engines accumulate mileage, oil change intervals may need to be shortened due to increased internal wear and contamination. Understanding oil change intervals. While newer engines may specify 7,500 to 10,000 mile intervals, high mileage engines over 100,000 miles often benefit from more frequent changes every 3,000 to 5,000 miles. This accounts for increased oil consumption, reduced sealing efficiency, and higher contamination levels. Choosing the right oil. Conventional oil, suitable for newer engines with regular driving patterns. High mileage oil, formulated for engines over 75,000 miles with seal conditioners. Synthetic oil provides superior protection and longevity, especially in extreme conditions. Synthetic blend balances performance and cost for moderate conditions. Always consult your owner's manual for viscosity specifications. Using incorrect viscosity can affect oil pressure, fuel economy, and engine protection. Step 6. Address fuel system contamination. Modern gasoline contains ethanol and various additives that can contribute to fuel system deposits over time. These deposits reduce fuel flow, alter spray patterns, and can cause carbon buildup throughout the intake system. Carbon deposit formation. Carbon deposits form when fuel and oil vapors bake onto hot engine surfaces. This is particularly problematic in direct injection engines, where fuel doesn't wash over the intake valves. Symptoms include reduced power output, engine knock under acceleration, poor fuel economy, rough, idle, hard. Starting fuel system treatment. Quality fuel system. Cleaners can dissolve deposits and restore proper fuel flow. Look for products containing polyisobutylene amine, PB, or polyisobutene amine, PIB, which are proven effective deposit control agents. Add the treatment to a nearly empty fuel tank, then fill with high-quality gasoline. Drive normally for several hundred miles to allow the cleaner to work through the entire system. You should notice improved throttle response and smoother operation within this period. Step 7. Replace wear items. Systematically. Even with perfect maintenance, certain components wear out and require replacement. Identifying and replacing these items prevents secondary damage and maintains optimal performance. Critical wear items by mileage: 30,000 to 60,000 miles. Spark plugs, conventional. Cabin air filter. Fuel filter, if serviceable, 60,000 to 100,000 miles. Ignition coils, platinum/iridium. Spark plugs. Timing belt, interference engines. Water pump, if timing belt driven. 100,000 plus miles. PCV valve and system thermostat engine mounts. Drive belts and tensioners. Spark plug. Replacement. Worn spark plugs can reduce power by up to 30% and cause misfires that damage catalytic converters. When replacing plugs, use the exact heat range and gap specified by the manufacturer. Pre-gap new plugs, even if they claim to be pre-gapped, as shipping and handling can alter the specification. Addressing leaks and seals. As engines age, seals and gaskets lose elasticity and begin to leak. Small leaks can often be addressed with seal conditioning additives, while major leaks require component replacement. Monitor oil consumption and look for signs of external leakage regularly. Conclusion: restoring your engine's performance doesn't require expensive repairs or specialized tools in most cases. By following these 7 systematic steps, you're addressing the most common causes of poor engine performance while establishing a maintenance routine that will extend your engine's life significantly. Remember that prevention is always more cost-effective than repair. Regular maintenance intervals, quality parts and fluids, and attention to early warning signs will keep your engine running smoothly for hundreds of thousands of miles. The key is consistency. Make these procedures part of your regular maintenance routine rather than waiting for problems to develop. Your engine will reward you with reliable performance, better fuel economy, and years of trouble-free operation.